Hello, I'm going to go over section 1.3, finally the trig function. Now this is a definition, so you would put the angle theta in standard position with the positive x-axis as your initial side, and then terminal side of the angle. If you go terminal side counterclockwise, there will be a positive angle. So terminal side is right here. And now choose any point on that terminal side and has an ordered pair representing the point is x, y. Then this is x, and you draw the leg to the vertical leg and y triangle. And this one is vertical leg y. And then r, which is hypotenuse, is r equals square root of x squared plus y squared. Now here's a definition of sine theta. Sine theta is defined to be y over r. Cosine theta is defined to be x over r, letter C, and letter S. And tangent theta is defined to be y over x. Tangent theta like this, y over x. And then cosecant theta is r over y. Secant theta is r over x. Cotangent is x over y. So this one is read like this, cosecant, and this is secant function. This is cotangent function. And we use the first three letters of each except cosecant, which if I use the same as a cosine and first three letter overlaps. So here I choose CSC, cosecant theta. And now sine function and first three letter sine theta, tangent function, first three letter tan theta. Now you must write the theta. Theta is representing the angle measure. So now let's go over an example using this definition. So I wrote an example right here. And terminal side of the angle contains point -4 and 3. That means -4 is x coordinate and 3 is y coordinate. So the terminal side must be in quadrant 2 because since x is negative. So you would have a terminal side over here. And now point right here is -4 and 3. And now I already provided the r equals 5, but r equals always hypotenuse value by the Pythagorean theorem, square root of x squared plus y squared. Now, if you square the negative, it's always positive. And so -4 squared is positive 16, 3 squared 9, which is square root to 25, which you would simplify as a 5. Now sine theta, so the angle theta right here is my theta, or something coterminous to that. So by the definition, sine theta is y over r, and y coordinate is 3, r is 5. Don't forget, r is always positive, and x is negative in quadrant 2, y is positive in quadrant 2. And now cosine theta by definition is x over r. X is given to you as -4, r is 5. And tangent theta is y over x. And so 3 over -4, or -3 over 4. Now cosecant theta is r over y. So you are inverting this fraction. So 5 over 3. Secant theta is r over x. So you're inverting this one, which is -5 over 4. Cotangent theta is x over r. So inverting this fraction, which is -4/3. And that's how you do an example if you know a point on a terminal side. So here's the next example, which I put it a little I put x and y coordinate negative number. So since x and y are both negative, x and y are both negative, and I will put the angle in standard position, so I will draw x-axis and then y-axis. And since x and y are both negative, your terminal side of the angle must be sitting on third quadrant. And so your angle from here to here, or something called terminal to that, is theta. And now point that's sitting over here, choosing any point, is negative 2 square root 7 is given to you, and negative 6 is given to you. So that means negative 2 square root 7 and negative 6 is given to you. So you draw the vertical leg toward always x-axis. And so this is negative 6, this is negative 2 square root 7. And by the definition, R is always square root of x squared and then y squared. But if you square the negative is always positive square, m plus negative 6 square. Now that's 2 to the square, always positive when you square that. 2 to the square is 4. Square root of 7 to the square is just 7. And then negative 6 times negative 6 is positive 36. 4 times 7 is 28 plus 36, and that's 64. And square root of 64 is simplified as an 8. And now if theta contains a 2x and y negative number, you know the terminal side angle is quadrant 3. And then the definition of 6 trig function says sine theta is y over r. Y is negative 6, r is 8. And this is a fraction, which is both are even number. So you must divide by 2. So 6 divided by 2 is 3, 8 divided by 3 is 4. You must simplify your fractions. Now cosine theta is x over r, and x is negative 2 square root of 7, r is 8. Of course here 2 divided by, I can cancel 2 over 2, and 2 times 4 is 8, 2 times the square root of 7, and there's a negative sign, so you would cancel 2 over 2. Your answer is negative square root of 7 over 4. Now tangent theta is y over x. So y equals negative 6 and then negative 2 square root of 7, y over x. Negative divided by negative is positive. 2 divided 6, 3 over square root of 7. Here you need to rationalize it by multiplying square root of 7. So 3 square root of 7. And square root of 7 times square root of 7 is just 7. You would rationalize that. Now cosecant theta is r over y. R is 8, y was negative 6. You need to invert this fraction. And so simplified is a negative 4/3. And a secant theta is r over x. You need to invert this fraction. And so negative 4 over square root of 7, and rationalize it by multiplying by square root of 7. And so negative 4 square root of 7 over 7. Now cotangent theta is x over y, and in this case you need to invert this fraction, so square root of 7 over 3. Now what I want you to notice that is that when the angles in quadrant 3, when angle is in quadrant 3, x and y both are negative. So sine and cosine both will be negative. R is always positive. And tangent, negative divided by negative become positive. So tangent is positive, cotangent is positive, everything else will be negative. And then when it comes to second quadrant, earlier example, second quadrant, x is negative. So x over r and r over x will be negative. And then y is positive, x is negative, so tangent and cotangent are also negative. So sine and cosecant are positive. So there is a part, all trig function is a positive on quadrant 1. Sine function, and that implies cosecant is positive. Tangent is positive, which means cotangent is also positive. The others, the rest of them will be negative. Cosine is positive, but sine and tangent are negative. And since cosine is positive, secant will be positive. So this, how you memorize this is all student takes calculus. All student takes calculus. All function in quadrant 1 is positive, sine is positive, cosecant is positive, all the others negative. Tangent is positive, cotangent is positive, all the others negative. Quadrant 4, cosine is positive, that means secant is positive, but all the other function will be negative. And if you keep that one in mind, we can determine by simply knowing the sign of any two trig functions. Any means sine, cosine, tangent, any one of those. So here is the next example. It is given, and cosine theta is given to you, and theta is in quadrant 4. So you will draw angle in quadrant 4 in standard position. And since cosine is x over r, you can use x as a 5, r as a 13. And since the angle is in quadrant 4, and you draw the right triangle this way. Now what's missing is this y value. And in quadrant 4, y must be negative. And by the Pythagorean theorem, it's a negative square root of 13 square minus 5 square. Because r square equals x square plus y square by Pythagorean theorem. R square is 13 square, x square is 5 square, plus y square. So y square equals 13 square minus 5 square. Y should be plus or minus square root to that, but it has to be minus because you're in quadrant 4. In quadrant 4, y coordinate is negative. So negative 169 minus 25 is negative square root 144, which is negative 12. That will be a y coordinate. 5 is serving as x, r equals 13, y equals negative 12. Then how do you find sine theta? By the definition, sine theta is y over r. So negative 12 over 13. Cosine theta is given to you. Cosecant theta is inverting this fraction, so negative 13 over 12. And cosine theta is given as a 5 over 13. So secant theta will be 13 over 5. Now tangent theta is y over x. So y is negative 12 over 5. Cotangent theta is x over y. So you need to invert this. Negative 5 over 12. Again, cosine and secant are positive in quadrant 4. And sine, cosecant, cotangent, tangent are all negative in quadrant 4.